Water scarcity is defined as not having enough natural freshwater sources to meet the demand of that area. As the world's population grows, the demand is overshadowing the supply of fresh potable water. To date, the sustainable use of water resources faces grand challenges. These grand challenges need to be met with innovations in the industry, which needs to be accelerated in the areas of water reuse, desalination, and aquifer vulnerability mapping. These innovations are needed to meet the needs of the world's population. Currently, over 2 billion people are living in regions experiencing high water stress, and this number is expected to only increase. Now, researchers and government bodies are taking action to help prevent the future of water scarcity, but still the methods of desalination and water reuse are not the most efficient processes. While desalination is wonderful for places with little natural freshwater sources, they produce a brine that can be environmentally damaging if not disposed of properly. This is why aquifer mapping is so important, to realize the vulnerability in the natural freshwater sources and make sure that the areas will continue to have natural water sources in the future.
Increasingly, groundwater pollution is starting to become a more concerning issue as the scarcity of potable water increases. As urbanization and extensive soil use for agriculture has significantly increased, so has pollution. For years, there have been studies done to mitigate this issue. However, they have been done manually and have been ineffective at properly displaying the scale of aquifer vulnerability. With the assistance of machine learning, however, we can start to scope out larger areas of land and find more effective solutions for a variety of vulnerabilities. A study conducted at the Sais Basin in Morocco tested multiple machine learning algorithms to find the most effective one at predicting these risks. Drastic RFMLP, the most effective model, was able to accurately plot and find where the highest risks were for pollution. The machine learning model was measured on its effectiveness using various statistical measures. It proved to be the most accurate that they used, and using this dataset, the researchers were able to pinpoint exactly which areas of the basin needed the most attention. This can allow environmental agencies to be aware of what areas need more attention than others, so that efficiency can be increased.
So, desalination is just taking salt out of the seawater, so as humans we can drink it. Desalination gives us clean water for drinking, farming, and just normal daily stuff. We use heat or pressure to clean salty water. Generally, dry places use desalination methods because they don't have too much rain or clean rivers. There are a few main ways to do this like HDH, reverse osmosis, or something called multi-stage flash. So, which method works best? Sciencemen tested different ways to remove salt from the water. However, they found that HDH is the best one because it uses less energy and makes water clean more than other methods. As you can see from the table, methods cost a lot of energy rather than HDH method. The main question is that, is desalination a good solution? The good things about desalination are, we get fresh water from the sea. It helps water problems for dry places. Also, we can use solar power to save energy. And it helps growing cities and population. But there are some problems which leads to why we don't use desalination everywhere. All the benefits aside, it needs a lot of energy, costs a lot of money, and makes all the waste that can hurt sea life. So yes, desalination helps with water problems, but we need to make it cheaper, greener, and deal better with the waste.
We use water recycling in to form a closed, reusable system of treated water to reduce pollution and protect our nature. This method is called the MBR-MD method. It is more effective than desalination. It creates a higher quality water. However, it takes more energy to do so. Initially, we were testing this method in West Center using direct wastewater in a controlled setting. After that, we went a step ahead and we went to a place called Huachuca in real life, and we tested our performance there, which was very good because we created a lot of potable water reuse. And the way we can see it in theory is in the graph which I've shown in figure 1. So the wastewater goes through the 3 different tanks. With the help of using air, which is compressed in different ways, and with the help of a GAC filter and UV treatment, we come to a point where we convert all the water and we separate it from the wastewater. Therefore, we get clean water. This initially results in a performance graph, may I say, which highlights that MBRMD method is more effective than desalination, although it does cost more energy to do so, which is very worth it because we do not want any bacteria or harmful pathogens in our water, which makes this method the most effective one.
So, in the conclusion, water scarcity in Western countries requires a combination of sustainable, scalable, and energy efficient solutions. The MBR-MD system offers a reliable method for water recycling and shows strong potential when integrated with renewable energy sources. HDS desalination presents a viable alternative, particularly in coastal areas, and its environmental impacts are managed effectively. Aquifer protection through machine learning at first step layer of prevention by identifying and mitigation of water pollution risk before they escalate. These solutions, when implemented together, can form a comprehensive strategy and strategy to combat water scarcity.